August 28th, 1990. The sky grows dark over the small town of Plainfield, Illinois, while thousands of residents carry on with their daily activities, completely unaware that just to their northwest, one of the worst tornadoes in U.S. history is racing directly towards them. It's a hot and humid summer afternoon in northern Illinois, and severe thunderstorms are beginning to build along the horizon. However, to understand why this is happening, we need to turn back the clock 24 hours. It's August 27th, and the ingredients for a potent severe weather day are beginning to fall into place over the Midwest. Meteorologists are scanning the atmosphere, looking for 4 key ingredients that lead to the formation of severe weather. These are moisture, instability, wind shear, and lift. Moisture is abundant in August across the Midwest as rich tropical air makes its way north from the Gulf of Mexico, causing dew points to rise into the low 80s. This extremely moist air, along with high surface temperatures from the summer heat, are creating an extremely unstable air mass with the amount of convective available potential energy, or CAPE, rising to an unbelievable 8,000 joules per kilogram, over 8 times what is needed for a thunderstorm to form. In addition to the explosive instability, a low-pressure system and cold front are moving in from the northwest, bringing in a broad trough of fast-moving winds in the mid-levels of the atmosphere, which are spreading apart or diverging over an area of relatively calm and converging winds near the surface. This difference in wind speeds at different levels of the atmosphere is called wind shear and helps to both force air near the surface to start rising and organizes a thunderstorm by tilting it on its side and separating the storm's updraft from its downdraft, preventing the storm from collapsing on itself and allowing it to persist for extended periods of time. With all 4 major ingredients for severe thunderstorms now in place, the National Severe Storms Forecast Center had enough confidence to issue a moderate risk for severe weather across northern Illinois for August 28th. However, there was still one crucial piece of the puzzle missing. Although strong speed shear was present in the atmosphere, the winds near the surface were not turning significantly with height. This gradual turning of the wind direction as we ascend through the atmosphere is called directional shear, and it's an important factor that causes a storm's updraft to begin rotating, a critical ingredient in the formation of tornadoes. With this important directional shear missing, the meteorologists at the Storms Forecast Center issued a severe thunderstorm watch at 1:30 p.m., anticipating a powerful line of severe storms to develop. However, because the atmosphere lacked significant low-level wind shear, they made no mention of the possibility of tornadoes. Just before noon near the Illinois-Wisconsin border, the incredible potential energy of the atmosphere could no longer be held back, and a cluster of thunderstorms exploded like a bomb. This cluster of storms would slowly drift to the southeast, producing damaging straight-line winds and large hail before one of the storms began to deviate from the others and quickly dominated the atmosphere around it. It's around this time, however, that something unexpected happens. The winds at the surface suddenly changed directions and began to blow to the northeast, increasing the low-level directional shear and transforming the dominant cell into a powerful rotating thunderstorm called a supercell, greatly increasing the risk for tornadoes. The momentum was building fast as this supercell developed a rotating wall cloud and produced a few brief, weak tornadoes as it passed between Rockford and Aurora, Illinois around 1:42 p.m. An already bad situation became worse, however, as the storm began to wrap its rotating updraft, or mesocyclone, in a thick curtain of heavy rain and hail called the Bear's Cage, hiding whatever tornadoes that may develop within, and at 3:15 p.m., that's exactly what happened. The newly formed twister started out as a weak F0, doing little more than damaging crops and open fields and periodically causing more concentrated damage as the subvortices danced within the parent circulation. It's now 3:23 p.m., and the National Weather Service office in Chicago, unaware of just how dangerous the situation is becoming, decide to issue a severe thunderstorm warning for the areas downstream of the supercell, but decide not to include any mention of the possibility of tornadoes. With that decision, those in the path of the storm will have no warning of the invisible monster roaring towards them. The tornado continues moving to the southeast, gradually building its strength when something remarkable happens. The tornado's parent storm may have ingested a nearby outflow boundary, pulling in the spinning air that exists along the boundary and leading it directly to the tornado. Like spraying gasoline on a raging fire, the tornado exploded in intensity right as it began to close in on the subdivision of Wheatland Plains. The tornado would strike the small community at 3:25 p.m., displaying its terrifying power as it caused major damage to dozens of homes and completely sweeping away 12 of them, scattering the remains of the structures for long distances downstream. The tornado also claimed its first life here in addition to injuring dozens more. However, the tornado was far from finished with its rampage. As the tornado crosses 135th Street, it begins to shrink in size, yet as the tornado shrinks, the winds inside the vortex strengthen at a frightening pace, quickly becoming violent, and as the twister crosses West 143rd Street, it reaches its peak strength. The winds inside the core of the tornado are now roaring at over 260 miles per hour, easily placing the twister at the top of the Fujita scale, a rare F5. The now F5 winds of the vortex flatten hundreds of yards of crops and drill into the earth, causing intense ground scouring and tearing away several inches of the soil before exiting the field outside of the town at 3:28 p.m. Like a cloaked monster, the heavily rain-wrapped vortex crosses Route 30 in Illinois 126, picking up several cars and a 20-ton tractor-trailer like toys before throwing them over half a mile away, killing their occupants upon impact. Weakening slightly to high-end F3 strength, the tornado then crashed into the southwestern side of Plainfield, closing in on the town's high school, where several dozen students had just run inside the gymnasium to take shelter after seeing the eerie green storm clouds of the approaching storm. As soon as the last student made it inside the school, the doors of the hallway they were sheltered in were ripped away with terrifying force as the roof collapsed around them. Remarkably, the hallway the students had sheltered in would be the only part of the building to survive the winds of the twister. Tragically, 2 maintenance workers, an administrator, and a teacher outside this hallway would be killed as the building collapsed around them. With brutal force, the core of the tornado then slammed into St. Mary's Immaculate Church, severely damaging the structure and killing 3 inside before mowing down dozens of homes and a grocery store with such ferocity that some were completely swept away with only their concrete foundations remaining. Trees here became so badly damaged that their bark was stripped off their trunks, and a video in this area revealed the winds became so intense that a steel dumpster was picked up and crushed beyond recognition before being wrapped around a nearby tree. The damage here was so violent that it earned a high-end F4 rating, and unfortunately, at least 9 people would lose their lives here, with countless others severely injured. There was a brief lapse in the tornado's strength as it exited Plainfield before it once again intensified back to F4 strength and set its sights in the city of Joliet. The invisible vortex smashed into the Crystal Lawns and Warwick subdivisions with terrifying fury, lofting vehicles into the air and destroying countless homes at F4 intensity as it narrowly missed the Joliet Mall, claiming 8 more lives. By 3:38 p.m., the tornado was now losing steam and slowly weakening, yet in a cruel final blow, the dying vortex strikes the community of Crest Hill, destroying several apartment buildings and sucking 8 people from their homes and hurling them into a nearby cornfield before striking a vehicle and killing 2 more. The rapidly weakening twister would damage a few more homes downstream of the apartment complex before finally roping out and dissipating at 3:45 p.m., 2 miles east of downtown Joliet. By the time the tornado had lifted, 29 people had tragically lost their lives, with hundreds more sustaining life-altering injuries and over 1,000 losing their homes. In the span of just 30 minutes, the invisible and unwarned tornado carved a continuous 16-mile path of destruction as it traveled in a bizarre southeasterly direction, causing over $375 million in damage and vanished without a trace, cementing its legacy as not only one of the strangest and mysterious tornadoes in U.S. history, but also the only F5 tornado to strike the United States in the month of August, leaving behind both physical and emotional scars that would take years to heal. However, as the devastated communities began to pick up the pieces, one question lingered in the minds of the survivors. As soon as the Plainfield tornado had lifted, questions about why there had been no tornado warning quickly began to mount among the survivors. Amidst the increasing public backlash, the National Weather Service would launch an internal investigation into its Chicago office to determine exactly what had gone wrong on the afternoon of August 28th. The investigation found that the critical failures that led to the Plainfield tornado striking without a tornado warning stem from the fact that the forecasters had failed to recognize the well-known signs that the storm tracking through northeastern Illinois that day was in fact a tornadic supercell nor was adequate preparation or infrastructure put in place for the office to receive reports of severe weather from either the public or trained weather spotters. On the day of the Plainfield tornado, none of the funnel cloud or tornado reports that occurred prior to the Plainfield F5 touching down ever made it to the National Weather Service office in Chicago, nor was the classic hook echo shape of the parent storm visible on radar recognized by the forecasters as the telltale sign that the storm was in fact a long-lived tornadic supercell capable of immense destruction. And ultimately, the National Weather Service failed the people of Plainfield that day. Yet, from this terrible tragedy came enormous progress. In the 33 years that have passed since the Plainfield tornado, things have drastically changed at the National Weather Service. In place of what was once a limited range of tools, training, and communication, has blossomed into a plethora of upgrades that let meteorologists peer inside a thunderstorm from both the skies above and the ground below. With the deployment of both an upgraded dual polarization Doppler radar and the use of an extensive network of volunteer storm spotters through programs like Spotter Network, Skywarn, and even social media, the National Weather Service can see exactly what is happening on the ground in real time and ensure that a disaster like Plainfield can never happen again.